Today I'm going to be going over Module 10 for 436. My name is Shemaisa Qureshi, and we'll be detecting patient change using control charts. I'm going to walk you through the 3 statistical charts that help us determine if a patient's health status and exercise behavior have changed over time. We'll use an actual patient's data and explain each method step by step. So first we have to understand the data. The assignment provided us with 2 types of data that we'll explore from both a clinical and behavioral perspective. The first is the patient's self-rated health scores over 8 distinct time periods. These scores help us detect possible shifts or outliers in perceived health. The second data set tracks daily minutes of exercise over a 14-day period. For this, we'll define a successful day as any day with 30 or more minutes of exercise. By analyzing both sets, we aim to answer 2 questions. Has the patient's health shown any meaningful change, and has their behavior, specifically their exercise habits, become more consistent or irregular over time? This combination allows us to evaluate both short-term health trends and longer-term behavioral patterns that could impact health outcomes. What are control charts? Control charts help detect meaningful change from randomness, so each chart type gives us a different lens into the patient's stability or variability. They help detect unusual variations, such as inconsistencies in discerning data, monitor consistency, identify when change occurs. There are 3 types of control charts that we'll specifically be using today. We have the XMR, which is an individuals and moving range based control chart. And we have a Tukey or a box plot. We also have the time in between chart, which is behavior based. What are XMR charts? So XMR is individual measurements and moving range. So for this, we will need the mean, which is the average of all scores, the moving range, which is the difference between consecutive scores, the UCL and the LCL values, which are the boundaries which we calculate using this formula. So for UCL, we would need the mean, meaning the average of all the scores, and then we add 2.66, and then we multiply the meaningful range, or the moving range mean. And then we have the LCL, which is the mean, where we subtract 2.66 and then multiply the moving range. So XMR is especially useful with small data sets. We use the moving range to calculate whether a new score is within the expected range or if it's potentially signaling change. So now we can go over and analyze the XMR chart results. So here our findings show that there are no interventions. First, we should point out that there are no interventions, and therefore the entire data can be used to estimate the control limits. So the control value, the mean, is 87.38. I use the formula in Excel with the data set. And then we have the UCL, which is 124.62, using the formula I showed you guys right before this, and then the LCL, which was 50.13. So no points exceeded the UCL or the LCL. So this means that there was no statistical significant change in the patient's health. However, there was one significant drop under time period 4, as you can see right here, time period 4, where the health score drops right here. We see that this is a drop near the lower control limit, which is also this purple dash line right here. So this could indicate a temporary decline in health, but not significant enough to trigger a full process change. The data then continues to the previous pattern as before and displays recovery and stability in the patient. Now, we want to go over what is a Tukey chart. So Tukey charts are known as box plots. They display range, median, and the outlier or outliers. The box is the middle or 50% of the data, Stats are the extreme values. So Tukey charts help visually identify the distribution and consistency of data. The box represents the middle /50% of values, while whiskers show the spread. If a data point appears far outside the whiskers as a dot, it's considered an outlier. This can signal irregularity, instability, or an unusual event that warrants further review. So now let's go over the Tukey chart results. The box is centered around 85 to 92, as you can see right here. This means most scores are within this healthy range. The X in the box is the mean, which is roughly 87, which is close to the median line. This indicates the data is pretty symmetrical and stable. The one red dot below the box at 67 right here is marked as the outlier. That means that it confirms what we observed in the XMR chart, the significant drop at time period 4. The rest of the scores are grouped with consistency and there are no long whiskers or skewing, as you can see. So what are time in between charts? The purpose of these charts are that they measure consistency between success. So success is equated to 30 minutes and up of exercise. It counts the days between success events. This chart tracks behavior. A short and steady number of days between successes suggests a consistent routine, while longer or fluctuating gaps indicate irregular behavior. We want to see if the patient is getting more consistent over time or not, and whether the smaller gaps equal to more routine. So now let's go over our results with the time in between charts, which we created. The chart displays days between successful exercise days. We derived this from the data. So the success days, as shown from before, is 30 minutes or more of exercise. And we see that in day 2, day 3, day 8, and day 12. There were gaps from day 2 to day 3. Well, there was no gap between day 2 to day 3, but then in day 3 and day 4, there was a 4-day gap. In day 8 to day 12, there was a 3-day gap. So the first 2 successful days, day 2 and 3, are immediate. So this shows initial movement or effort. And then after day 3, the patient goes 4 days without a success, as you can see right here. And then we see a depletion again, where the patient goes 3 days without a success. So this suggests a depletion in consistency. The optimal results would be the number of days between successes shortening. Rather, here we see an inconsistency and a continual depletion. There is a success, but time between exercise successes increases then decreases, showing an inconsistent habit rather than sustainability in behavior. There's an early set success, sorry. So now we're going to compare all of the charts. Here we see the Tukey chart, the time in between chart, and then the XMR chart. So what we're going to do is go over how all of these charts and the results play in together to show us our results in analyzing the changes in the patient. So together these charts present a comprehensive picture. The patient's health appears mostly stable, with one noticeable low point flagged by both the XMR and the Tukey chart. The outlier at time period 4 suggests a temporary dip in health, but not an overall downward trend. On the other hand, the time in between chart reveals irregular exercise behavior, with gaps of 0, 4, and 3 days between successes. This pattern indicates the patient has not yet developed a consistent exercise habit. While the health status remains statistically in control, the inconsistency in behavior suggests that sustained improvement in physical activity has not yet occurred. So again, right here we see that the XMR is detecting health changes, which is coming up as mostly stable, but then we see that drop at that time drop at 4 right here, time period 4, and then we see in the time in between chart and the Tukey chart, we're seeing the habit pattern is being detected in the time in between chart, where we see inconsistency in exercise gaps. The Tukey chart, we're seeing the health spread, and we see there was the outlier. So in conclusion, while there was no drastic change, we can see early signals worth paying attention to, and this kind of analysis helps catch early changes early on, even without intervention. So we can say that the patient, the health stat of the patient displayed that there was a one-time drop, but overall there was stable data, and in terms of exercise, there was no steady improvement in the pattern. So the key takeaways here are that the patient's health is mostly stable, and behavioral changes in exercise is inconsistent. So the recommendation that we can derive from this statistical analysis is that there should be continuous monitoring of both health score and exercise consistency for the patient. Thank you. And here are my references. If you have any questions, please go ahead and leave them, and I will try and address them. Thank you.